Today we'll be looking at the miniDSP 2x4 HD high-performance digital signal processor. Here we have the input panel of the 2x4 HD. From left to right you'll see two analog inputs, a Toslink optical input, a USB input which is used both for streaming audio as well as computer control of the 2x4 HD. Finally, we have the infrared remote control input. Here we have the output panel of the 2x4 HD with the four completely independently controllable RCA analog outputs. The functional block diagram depicts the flow of both digital and analog input signals all the way through the 2x4 HD to its four analog outputs. We see here the USB and optical digital inputs as well as the analog inputs, which are selected and then immediately go into precision digital gain level controllers. The two parametric equalizers on the input and routing section precede the routing matrix. These provide comprehensive audio frequency response shaping. We'll go into more detail later. The routing matrix is a critical element of the 2x4 HD. It allows the overall system to be configured in many ways. Any of the two inputs can be routed to any or all of the four outputs, allowing for a wide variety of system configurations. Examples range from active two-way crossover systems to multi-subwoofer home theater systems. The four outputs of the routing matrix enter another set of four parametric equalizers, which we'll discuss in more detail in a minute. Following the parametric equalizers, we enter four comprehensive crossover elements, which can be configured as high and low pass filters with varying slopes and filter shapes. Finally, the four output sections allow for adjustable gain, adjustable delay, channel inversion, as well as channel muting. The miniDSP 2x4 HD is controlled from a software application called a plugin. Here we have the plugin input page where we have the input level selectors, the first parametric equalizers. The routing table allows any of the two inputs to be routed to any or all of the four analog outputs. In this configuration shown here, input 1 is being sent to output 1 and 2, and input 2 is being sent to outputs 3 and 4. This would be typically used in a two-way active crossover. If this were a dual input home theater subwoofer system, this configuration would allow two stereo inputs to be monorailized and sent to four outputs, driving four active subwoofers. From the input page, we can go to one of the two input side parametric equalizers. Each one of these equalizer banks has 10 variable filters which are completely independently configurable. We'll start here on filter 6 by adding a peak filter at 1000 Hertz and a Q of 0.7. We can then, after adding the gain of 14 dB, we can vary the frequency anywhere from 10 Hertz up to 20 kilohertz. And then the Q can be varied anywhere from 50 to 0.5, and the higher the Q number, the narrower the filter shape. Finally, you can choose the filter type. What we're seeing here is a peak, and here is a traditional low shelf, much like a bass tone control on your receiver or amplifier, and then a high shelf. These also have the flexibility for being moved in the frequency domain, as well as they can be made for gain or for loss. From the outputs page, we have access to the crossover controls. The crossover controls have a high pass and low pass filter, which are completely configurable, and these are available on all four of the output channels shown here. We're working on the output channel number 1 filter, and currently it's set as a simple bandpass filter with a 10 hertz Linkwitz-Riley, and over here at the top end we have a 20 kilohertz Linkwitz-Riley 48 dB per octave filter. I'll show a typical example of setting up an active two-way crossover filter. I'll start with the high pass section having a crossover frequency of 2 kilohertz. So here you can see the resultant bandpass filter for the tweeter with the crossover point of 2 kilohertz. Now we'll set up the low pass filter section for the woofer. We'll choose a low pass frequency of the same 2 kilohertz, which creates the crossover junction between the woofer and the tweeter. We now have flexibility over varying the shapes of the filter. The Linkwitz-Riley 48 dB per octave is a very steep filter, and for example, we could choose a Butterworth 6 dB per octave filter, which is a very soft, shallow slope filter. Finally, on the output section, we can individually adjust the gain of each of the output levels. This could be for matching a subwoofer to a full range speaker or for setting up a two-way active crossover. Next, we have a compression section where we can go in and add compression for speaker protection. Following that is a finite impulse response filter system that we'll take up in another presentation. This row here is for setting individual delay in milliseconds, which can be varied by using the up-down arrows here. Next, you can invert each of the channels, four output channels, independently. And finally, if you choose, you can mute each of the four output channels independently. Thanks from all of us at Deer Creek Audio for watching this brief explanation of the miniDSP 2x4 HD. Feel free to contact us at Deer Creek Audio with any questions you may have.